Hi everyone, welcome to the second video on Pythagoras' theorem. The first video looked at how to find the length of the hypotenuse of a right angled triangle. Today what we're going to be doing is looking at how to find one of the shorter sides. Now, a triangle has three sides, it has one longest side, and so it has two shorter sides. So this method applies to finding either of the other sides that's not the hypotenuse. First thing we're going to do is exactly the same as the previous video. We are going to label our sides. We are going to start by labeling the hypotenuse. Now the hypotenuse, remember from the previous lesson, is always across from the right angle. So here is the hypotenuse in this first example, and here is the hypotenuse in the second example. The hypotenuse, remember, is always going to be called C. So this is side C. The difference with these examples is if we have an unknown on a shorter side, we're going to call that shorter side A. Okay, so if there's a missing side and it's not the hypotenuse, we're going to call that missing side A. So here's A in both cases, yeah, the missing side, and that leaves the other side to be called B. Okay, so we're using the letters A, B, and C. So let me just go through that again really quickly. Put on your hypotenuse across from the right angle, call it C. If your missing side is a shorter side, we're going to call it A, and then we're going to call the remaining side B. Okay, we're going to start with our formula, same as before. So it was that C squared is equal to A squared plus B squared. And we're going to substitute in what we know again. Okay, so far so good, exactly the same as the last day. And here's where things get a wee bit different. What we've got now is we've got a little equation that we have to solve where the unknown's not isolated on one side. Okay, so we're going to take a really simple step at this point just to make this look like last day's questions. And what we're going to remove this adding 3 squared by doing the opposite operation. We're going to take 3 squared away from each side of this equation. Okay. So this is the one kind of new step in this process. So we're going to take 3 squared away from each side. So this 3 squared, take away 3 squared, of course, leaves us with nothing. So we're just going to have A on this side now squared. But on this side, we've got 5 squared, take away 3 squared. You don't need to compute that at this point. We're just going to write down that that is what we're trying to do. Okay, I'm out of space again, so I'm just going to come over here. And at this point, you might want to reverse things round. We're starting to solve the bit on the left hand side. I'm going to leave it there just now, and I'll maybe spin it around a little bit later. So we've got 5 squared is 25, take away 3 squared, which is 9, and that's equal to A squared. 25 minus 9 is 16. I think this is probably the best point to spin things around because you just got one term on each side. If 16 is equal to A squared, then A squared is equal to 16. We're going to take the square root of each side, same as before now, square root of 16. And this one works out really nicely, yeah. If you try to do a square root mentally, remember you're just thinking, well, what number squared gives me this number? And of course the answer to that in this case is 4. Don't forget your units, 4 centimetres. Okay, so a little bit of additional working this time where we've got this rearranging of the equation that we didn't have in the previous examples. Okay, I'm actually going to take this diagram away. That'll give me a wee bit more space now. And we'll have a go at example 2. Okay, let me just put my C back in here. There we go. All right, so we're going to try and find the length of the missing side for this one. Start with our formula. C squared equals A squared plus B squared. Substitute in what you know. Okay, C is 12. A is the thing that we're trying to find, and B is 7. Okay, new step here, remember. We are wanting A squared to be on its own, the variable isolated on one side, so we're going to remove the 7 squared from this side. However, if we remove it from that side, we also have to remove it from this side, just our rules of equations. This gives me this statement over here, 12 squared minus 7 squared equal to A squared. And from here, we're going to do some subtraction. So 144 minus 49 equals A squared. If we do our subtraction here, we get that A squared is equal to 95. This is the point at which I'm going to spin this round. So A squared equals 95. And I need to work out now the value of A which is the square root of 95. Okay, so the square root of 95, and you can see we get, again, one of these big, long, irrational numbers. So 9.746794,345. 3 decimal places at this point, so we're going with the A is equal to 9.746, and so A is equal to 9.7, correct, to 1 decimal place. My units are centimetres. Okay, let's keep going. So one more example. I'm going to go from start to finish with this one. So first thing, label your sides. Okay, we're looking for C. So here's my right angle, we arrow across the way, there's C. The missing side is a shorter side, I'm going to call that A, and there's B. Okay, so here we go. C squared is equal to A squared plus B squared. 14 squared is equal to A squared plus 6 squared. We're going to remove our 6 squared from each side, so remove 6 squared from that side, need to do it from this side. So we've got 14 squared minus 6 squared equals A squared. You can put this in your calculator at this point and go straight to the solution. I'm just trying to show you all the different steps, so this next step is kind of optional. Yeah. You could go from here straight to this next one, which is the A squared is equal to 160. Alright, I'm just going to spin things round. Just prefer having A on the left hand side. A is equal to the square root of 160. A is equal to square root of 160. So square root 160, and that gives us 12.64911,064. Again, I'm going to write down 3 of those digits after the decimal point. That goes on for a little bit, and then we're going to just round this to 1 decimal place. 12.6 centimetres, correct, to 1 decimal place. Okay, that's how you find the shorter side of a right angled triangle using Pythagoras' theorem. The next video is going to have a little look at how do we know if we're finding the hypotenuse or a shorter side. Can we try and identify that ourselves moving forward?